Hi, everyone. I'm Daniel, and welcome to the Light Your Candle podcast. On this episode, I would like to discuss the nature of light. What exactly is light? It beams down from the sun, warming and brightening the earth. And at night, it illuminates our streets and our homes. It shines out of our tablets and television screens. It's how our smartphones and laptops talk to each other. And it's how we learn about the stars. It is the primary way we humans have come to understand the world we live in. In a very real way, light is the universe's way of communicating with itself. We all have a very intuitive understanding of what I'm talking about when I say light. It is, after all, what our eyes use to see. The same way sound is what our ears use to hear. But what exactly is light? Light is made up of energy, pure energy. As for what energy is, well, we don't have a great answer for that at this moment. We can model it, explain its effects, and its properties, but energy itself, so far as we understand it, is a fundamental part of nature. It just is. We'll go into more detail about energy another day, but what we do know about energy is that it can do stuff. You can think of it as potentiality. Energy is potentiality. Just stop and think about this idea. What is potential? What does it mean to you? When you have the potential to act or react or change things, what does that mean? Now, with that idea of light in mind, let's take the sun, the main source of light for the Earth. The sun pours down energy onto the Earth every second of every day. This gives rise to the weather, to ocean currents, and most interestingly, to life. But how does this energy shine down? Well, just like waves in the ocean, light is a kind of wave that moves from one place to another. So now we can begin to add to our understanding. Light is the movement of energy from one place to another. The same way a wave in the ocean is a disturbance in the water that travels through the ocean from one location to another. Light is a disturbance that travels through space from one location to another. But what exactly is light a disturbance of? So, it turns out there is a field that permeates the entire universe. The same way water permeates the entire ocean, or air permeates the atmosphere. We have given it a name. It's called the electromagnetic field. It has that name because we discovered it by trying to work out how electricity worked. And at the same time, we were trying to work out how magnets worked. And then realized the same thing was responsible for how both worked. That name doesn't really matter though. Nature doesn't have names for things. Nature just is. This field is just there. So let's just call it the EM field. But the name really doesn't matter. You can call it whatever you like. What's important is how you think about it. So in this case, think of it as the ocean that light moves through. The same way waves on the ocean move through the ocean. Now we can build up our understanding further. Light is the movement of energy from one place to another through the EM field. If we are talking about visible light, the light we're all very familiar with, then I'm talking about disturbances in the field that can be perceived by the human eye. And when it comes to the color, well, that is the frequency of the light. How much it is vibrating, that determines what color we perceive it to be. And it turns out that the higher the frequency, the higher the energy of the light. Red being the lowest frequency, and violet being the highest frequency we can see. Rainbows are a great example of this. Now, I want to try to take a second to tease out just how amazing it is that we can see it all, that we can make sense of the light that's out there in the world. So I want you to think about a pool with lots of people swimming and jumping in it. The waves in the water would be very choppy, with waves going this way and that, some bigger, some smaller. Now imagine that in one of the corners of the pool, there's one of those little water strider insects. You know, one of those insects that can stand on water. And imagine if somehow, using its clever little insect brain, that based on how it was being bumped around by the waves on the water, that it was able to work out what was happening at any place in the pool. Who jumped in where, who splashed who, all that stuff. Well, this is exactly what we are doing when we look at something. You see, the light in the room is just waves. And just like the waves in the pool, except in 3 dimensions, not 2, the waves are just going up and down, left to right, all over the place. It's a complete mess. And yet, we have 2 tiny little holes in our head, which these waves enter in, and our brain works out what caused the waves, which is how we know what we're looking at. Despite this great mess of waves, we're able to work out just what the hell's going on. The same way there are sounds which lie outside the range of the human ability to hear, there are also frequencies of light which are outside the human ability to see or to directly interact with. Now, if we were to represent the spectrum of light as keys on a keyboard, then if we start down at the lowest frequency, so radio waves, then we would have microwaves, then we have infrared, then we have red, and the beginning of the visible spectrum. That would be violet now. Then we have the ultraviolet, and then X-rays, and then we have gamma rays, and then we have the cosmic rays. However, unfortunately, my keyboard doesn't go all the way to cosmic rays. It turns out that there actually is another part of the spectrum of light that we can perceive. That would be infrared, which we perceive as heat. So anytime you've walked out into the sun or under a hot light bulb and felt the heat on your skin from the light bulb or the sun, you're actually feeling the infrared light coming from that object. We're not able to see it with our eyes, but we're able to feel it with our skin. So in fact, we have to add a few more things to that great big mess of light flying around the room. For one, we have to add infrared light that could be coming from the heat of the TV screen or your own body heat. Then there would also be radio waves moving through the room, coming from radio broadcasts hundreds of kilometers away, as well as X-rays and cosmic rays coming from outer space. These are also in the room, adding to the complexity of the ocean of light. Again, with the exception of infrared, which we perceive as heat, we are completely oblivious to these other forms of light. But they are absolutely there, adding to that mess of light waves all around us. It's really there, guys. I'm not making this up. This is happening all the time, and I can prove it. Go turn on a radio or go on Facebook using 4G or Wi-Fi. Those are all waves moving through the room, and these tools are just tuning into them. Finally, you may ask, why out of the entire spectrum of light can we only see such a small part? What makes the visible part, the rainbow, so special? Well, it turns out visible light happens to be the frequencies for which water is transparent. That is to say, passes through the water easily. Which makes sense. If you're going to try evolve an eye underwater, you should probably use the frequencies of light which can actually move through the water easiest. And that's it for today's episode. Until next time, take care of each other.